All right, get ready to dive deep because today it's all about Erwin Schrödinger, a real giant in the quantum world. And we've got a fantastic essay by Jörg O. Schneppe as our guide.
It's fascinating. Schrödinger wasn't just content with the math behind quantum mechanics. He really wrestled with what it all meant, the philosophical side.
Yeah, he was grappling with the nature of reality itself.
Yeah.
And that's what makes his story so interesting. Schneppe points out how, even early on, born back in 1887 in Vienna, Schrödinger had this drive to truly understand, not just solve equations.
Right. He wasn't satisfied with just crunching numbers. He wanted an intuitive grasp of how the quantum world worked.
And this was at a time when classical physics was failing, couldn't explain things like how atoms and light behaved.
Imagine that, a whole scientific worldview, centuries old, falling apart, making way for a whole new understanding of the universe.
Must have been an exciting but also a pretty unsettling time for physicists. So how did Schrödinger fit into all this?
Well, in 1926, he drops this bombshell wave mechanics, a completely new way to look at the quantum world.
Before Schrödinger, we're picturing particles like tiny little billiard balls, right?
Yeah.
With definite positions.
Yeah, very classical Newtonian way of thinking.
Right.
But Schrödinger comes along and says, what if, instead of these points, these quantum objects are more like waves spread out in space?
So instead of knowing exactly where something is, we have these wave packets, these blurry clouds of probability.
Exactly.
Yeah.
And to describe these wave packets mathematically, he gives us the famous Schrödinger equation.
Now, I have to admit, that equation makes my head spin a little. But I guess it's safe to say it's the foundation of modern quantum mechanics, right?
Oh, absolutely. Think of it like the operating system for the quantum world. It lets physicists calculate how these wave packets change over time, how they interact. It's been incredibly powerful, used in everything from molecular physics to solid-state physics, and it's even behind technologies like quantum computing and cryptography.
It's amazing how one equation has had such a huge impact on science and technology. And what's even more fascinating is that, at the time, Schrödinger's wave mechanics wasn't the only theory out there. Werner Heisenberg had his own matrix mechanics, which focused on different aspects of quantum systems.
So two totally different approaches to understanding the same quantum reality.
Precisely. And get this, they seemed completely different at first, but it turned out they were mathematically equivalent. Just different perspectives on the same phenomena.
That just shows you how deep and complex the quantum world is.
Absolutely. But let's go back to that Schrödinger equation for a second. It's based on this idea of a wave function that describes a quantum object state. And the square of this function gives us the probability of finding that object in a specific spot.
Okay, so this is where things start to get really weird. Instead of knowing for sure where a particle is, we only have probabilities, a bunch of possibilities. It's like the universe is playing dice with reality.
And that's what really bothered a lot of physicists, including Schrödinger himself. This probability-driven view of reality was a huge departure from classical physics, where things had definite properties, whether we observed them or not.
Right. In classical physics, you could, in theory, predict the future perfectly if you knew everything about the system at the start. But in the quantum world, it seems like chance and uncertainty are in charge.
And this fundamental shift in how we understand the universe is what Schrödinger grappled with throughout his life. It's what led him to that famous thought experiment, Schrödinger's cat. Now, Schrödinger's cat, people think of it as this, fun thought experiment, but it was actually a pretty sharp criticism of how people were interpreting quantum mechanics back then.
Right, the Copenhagen interpretation, the one pushed by guys like Niels Bohr and Werner Heisenberg.
Exactly. They argued that until you measure a quantum system, it exists in this superposition of states. And it's the act of measuring that forces it to pick a specific state.
So before we look, the particles in this weird limbo, existing in all possible states at once.
Yeah, that's the basic idea. And Schrödinger found this really troubling, especially when you apply it to things we see in everyday life.
Hence, the poor cat stuck in the box with the radioactive atom and the poison.
It's a brilliant analogy. The cat's life depends on the atom, which, according to Copenhagen, is both decayed and not decayed at the same time until we open that box.
So until we look, the cat's both alive and dead. That seems crazy.
I know, right? That's what Schrödinger was getting at. It's absurd to apply these quantum principles to everyday stuff. He was arguing reality can't be so dependent on the observer. The cat's got to be either alive or dead, whether we look or not.
It's like he's saying, hold on, folks. Haven't we taken this a bit too far?
Exactly. He thought there had to be a better explanation of quantum mechanics, one that didn't rely on us creating reality just by observing it.
Yeah.
You can really see his philosophical side coming through and his discomfort with the Copenhagen interpretation.
Yeah, it's fascinating. He wasn't just a math whiz. He was really thinking about the deeper meaning of it all.
Absolutely. And his views on quantum mechanics were actually influenced by his earlier work in other areas like statistical mechanics and optics.
Schneppad talks about that in the essay. How did that earlier stuff connect to his quantum work?
Well, he was really into the work of Ludwig Boltzmann, this pioneer in statistical mechanics. Boltzmann's ideas about probability and how huge numbers of atoms behave really resonated with Schrödinger. And it definitely shaped how he thought about quantum systems.
So even before he dove into the quantum world, he was already thinking about the role of probability in physics.
Yeah, exactly. And his expertise in optics, particularly wave theory, that was crucial when he developed wave mechanics. He had this deep understanding of how waves work, their interference patterns, diffraction, all that stuff. And that knowledge really fed into his revolutionary idea that particles can act like waves too.
It's like all these different parts of his scientific journey came together to create this amazing breakthrough.
It really does show how different areas of science can connect and the power of having diverse knowledge.
But even though he made these huge contributions to quantum mechanics, Schrödinger never fully accepted how most people interpreted his own theory.
Right. He wrestled with the philosophical implications of it all his life. Even explored the connections between quantum mechanics and consciousness later on in his career.
So he was a real polymath, a scientist who wasn't afraid to dive deep into the philosophical side of his discoveries.
Absolutely. And his legacy goes way beyond equations. He pushed us to really think about the limits of our understanding of reality, to question how observation and measurement work at the most fundamental level.
And it's a legacy that continues to inspire both physicists and philosophers.
For sure. And as we keep exploring deeper into the quantum realm, guided by pioneers like Schrödinger, who knows what other mind-blowing discoveries and philosophical puzzles await us.
Now, let's shift gears a bit and talk about the more practical side of Schrödinger's legacy. Because his theoretical work actually laid the groundwork for some of the most cutting-edge technologies we see developing today.
That's right. From quantum computing to quantum cryptography, Schrödinger's ideas are shaping the future in really big ways.
It's pretty mind-blowing when you think about it. These concepts, like superposition and entanglement, they seem so abstract, yet they're driving real technologies.
It really is amazing. It shows the power of basic research, how ideas that seem purely theoretical can end up having a huge impact on our lives.
Let's start with quantum computing. Feels like it's about to revolutionize everything, from medicine to material science.
It really does have that potential. And it all goes back to Schrödinger's wave mechanics, the idea that these quantum objects can be in multiple states at the same time.
Right, that whole superposition thing. But how does that actually translate into computing power?
Okay, so imagine a regular computer bit. It can be a 0 or a 1, like a switch, on or off. But a quantum bit, a qubit, can be both 0 and 1 at the same time in superposition.
So it's like the switch is both on and off.
Exactly. It's weird, right? Defies common sense. But that's quantum mechanics for you. And this ability to be in multiple states means a qubit can hold way more information than a classical bit.
So more information equals more computing power.
Exactly. Quantum computers can do calculations much faster than classical computers for certain types of problems because they can explore all these possibilities at the same time. Think of it like searching a maze. A classical computer tries each path one at a time, but a quantum computer checks all the paths simultaneously.
Wow, that's incredible. So what kind of problems are best suited for this quantum speedup?
Problems with huge amounts of data, complex calculations, things like designing new drugs, new materials, optimization problems, even breaking encryption, stuff that really bogs down classical computers.
So quantum computing could change whole industries potentially.
It really could. And it's all built on the foundation Schrödinger laid with his theoretical work. It's a great example of how abstract physics can lead to real-world technological advancements.
And speaking of real-world stuff, Schneppad also mentions quantum cryptography. How does that connect to Schrödinger's legacy?
Well, quantum cryptography uses another one of Schrödinger's big contributions, entanglement. It's this spooky phenomenon where two particles, no matter how far apart they are linked. You measure one, and it instantly affects the other one.
It's like they're communicating faster than light, which we know from Einstein is impossible.
Yeah, it's one of those mind-bending things about quantum mechanics that still has physicists scratching their heads. But this spooky action at a distance, as Einstein called it, it's actually super useful for security.
How so?
Say you want to send a secret message. In quantum cryptography, you can use entangled particles to create a key that only the sender and receiver know. Anyone trying to eavesdrop to intercept the message would disturb those entangled particles, and both the sender and receiver would know instantly.
Sounds like an unbreakable code, because any attempt to crack it sets off an alarm.
Exactly. It's a level of security you just can't get with classical methods. And it all comes back to Schrödinger's work on entanglement.
It's amazing to think that these crazy ideas from quantum mechanics are now being used to create ultra-secure communication systems.
It just goes to show that exploring the fundamental mysteries of the universe can lead to some really unexpected and groundbreaking technologies.
And it's all thanks to pioneers like Erwin Schrödinger. His curiosity, his willingness to think outside the box, it opened up these new frontiers of knowledge.
His legacy lives on, inspiring scientists, engineers, and philosophers, pushing us to keep digging deeper into the quantum realm and explore its endless possibilities.
Well, a huge thanks to Jürgo Schneeppert for his amazing essay on Schrödinger. It's been a real treat to explore this incredible physicist's work and the lasting impact he's had on science and technology.
Schrödinger's story really shows the power of human curiosity, the elegance of mathematics, and how deeply connected everything in the universe is.
And that's a wrap on our deep dive into the world of Erwin Schrödinger. Hope you enjoy the journey through the quantum realm. Until next time, keep questioning, keep exploring, and keep diving deep into all the wonders around us.